Hello everybody, this is a presentation for the Google Test Framework GMOC unit testing. Initially, I'm a C++ developer, and for all my C++ module development I have been using GMOC unit testing for verifying my code. Believe me, GMOC for unit testing is really an easy, comprehensive and expandable tool. So initially let's start with what is unit testing, and later on we will understand the much more in depth about the GoogleMocks. Unit testing every small unit of the developer's code is unit testing. Why is the unit testing necessary? To prove your code is bug free, thoroughly verified, and to show the results is as per the requirements specified. And the unit testing helps the developers to verify the code works properly. As I already mentioned, unit testing reduces the defects, it reduces the cost of testing as the defects are identified in very early stage of development, and it verifies the intermodule dependencies. If your module is dependent upon the input or is an output for the other modules, you can always see your module is bug free or it is verified. And it overall improves the overall quality of the code. It's usually run once on the build system, once in a day, to show that the unit testing results are verified and your code quality is up to the standards. So I would like to make you understand how to unit test your code. So to do that, I have a sample code with me. So let's go through the code and try to understand how do we unit test it. So this is a sample code I have written. And what is the intent of this code? It is inserting an input element in the requested position and returning back the resultant array. So how do I consider unit testing this part of the code? Whenever you want to unit test, there is two varieties of testing. One is called the happy path testing, passing the proper values and the code executes as expected. And another is called the bad path testing, pass the unexpected wrong values and test the behavior of your code. And luckily the code written here is already verifying that the null values are not inserted, and if you're inserting at the wrong positions, it already shouts. So I have written some unit tests here to verify that. So the first one is actually trying to pass a null value. Let's see how your code behaves. And the next one is actually passing it at the wrong position, and let's see how the code behaves. Currently I have already installed Google Framework and I'm going to test it with that, but now we are actually more interested to understand how do we unit test any code. So we are building this code. So here is the result of this is we have written the two unit tests, and you see the first unit test was to verify I shall insert an empty element into an array, and you see the empty element is not inserted, and I'm trying to insert the element at the wrong position, so there is already an error thrown. So this code is bug free, no one can try to insert at the wrong positions. This is a very small piece of the code that we're trying to understand, but the proper intention here is to understand what shall we unit test in any code. So back here, if you are trying to verify your code, there are usually these four categories that we try to unit test. We try to test a null values test, we do a boundary test, we do a bad input test, we do a regression test. Regression test is when any input fails, just stop the unit testing there. It exits if the pass condition is not passed. Hi all. After we understanding the unit testing, we shall now understand the Google Test Framework in depth. So for testing the C++ applications, there are so many other frameworks, but Google Test Framework is also one of them. The Google Test Framework comes in the two packages. The one is the test framework, the other is the Google Mock. So what is the test framework? The test framework provides you with a lot of facilities to run your test. It's a test bed where you can run your unit test for the C++ classes. But at the same time, the Google Mock provides you with the facility to mock your classes. There are some goodies that the Google Test Framework provides. It handles the bad memory, it repeats the unit test, built-in assertions, XML report generation. So now we shall see some of the goodies that it provides. I shall say, hey, repeat the test for 5 times. Yes, the 5 iterations it repeated. And I shall say, hey, put it into an output folder. And yes, it puts it into an XML format folder like this. So you can use this report to send it to your client. So these are some of the goodies it already provides. So after with a small introduction with this, we shall go for the installation and the usage. If you want to install this, kindly do download it from this path. It provides you with the complete package of the Google Test and the Google Mock package. Then in the step number 1, we export this required paths, then build the libraries separately, Google Mock and Google Test in step 2 and 3. Fourth is building a library Google Mock.a and then using it in your build systems. The 5th step, there is also a sample, kindly do it so. This is how it looks like when you run your Google Test unit test. So let's get more practical about it. After the installation, how do we start writing a unit test? First, include the header file called GTest.h. Then, like any other main function, when your main function, include the init Google Test and run all test as the step 2. And the step 3 is a small test function. What is it doing? It is trying to test the add function, whether it's returning 4 or not. So you can write such smaller functions to test your code. So this is a small introduction about how do you use the Google Test Framework to write your small tests. So that's it. You're already ready to start using the unit test framework. Now let's get a bit more depth into it. Understanding the test fixtures. Test_f is the macro that you use for the test fixtures. What is the test fixture? Text fixture is providing a well-known and a working environment so that the test can be repeatable. So for running your unit test, you need a preparation. You need the data input and to handle the output. So for all such things, that is called the preparation for the unit test that is provided by the test fixtures. So to understand this much depth, we will now again migrate back to our sample code to understand the test fixtures. I have already written here 2 tests. What is it doing? What are we trying to test? So there is something like a cscan class that I have written, which takes any folder and gives you all the possible files in that. So the developer here is trying to test the size of it. So he's trying to test the size is more than 10. And what is the second test doing? He is trying to do something similar, but is using the function display all files. Okay, fine. So to do that, what is it try? So to just do this, he is supposed to create an object, delete it, create an object, delete it. Yeah. So every time the memory is created and discarded. So let's try to run this. I've already run this once. So I'll just show you the output. So this is how it's run. Yes, it's running. Now let's tell you what is the usage of the text fixtures. I've already written the code. We'll explain you how and how useful is the test fixture. Okay. So when I say test fixtures, Step number 1, use the namespace. Step 2, to your unit test class, publicly inherit test, and when you input the test, you get the setup and the teardown functionalities. The setup is the code that executes before every unit test executes, and the code that executes after every unit test is completes. So I simply put my creation of the object here and the deletion of the object here. So this is the preparation for the test. Setup is a preparation for the test. So my now a unit test will change like this. It is just a single line of code now. It is very simple. So this is how the test fixtures are written. So I'll just explain you. I'll just run this code, build this, and show you the output. Hey, it's running. So what did we achieve with this? It's a better handling of the memory. We are not creating and discarding the memory again and again. So this is a better way of doing, a better preparation for the test. You write much, you can actually open the database with this. You can do much more varieties of the things that is required for the, this is called about the test preparation. So the next is the parameterized test. Test underscore p is the macro that is used for the parameterized test. Let's go for a sample example to understand the test parameterized. What are the parameterized test? Usually when you have to test, usually you do not test for a single input. You would like to test for the list of the inputs, a varieties of the inputs, a bad input or a good input. So in such a situation, Google Test Framework says, hey, we have something called a test patterns, or the test underscore p, test patterns, where you can simply give your list of patterns and I will run the unit test for every single input that you provide. Hey, great. How do we achieve that? Here I have written, you have to now you have to inherit from the test with param. Same setup I have, same teardown I have written one small test pattern here. So as per the definition, now it says this particular test will take 4 or 5 inputs, or say more than 10 or 20 whatever, and run this test for each and every input that you pass. What is the one more important step I need to do? You need to say initiate test case underscore p default input and provide the test name here and provide all your inputs in the array. So my test is now going to be run 4 times and it will every time test, hey, is the output more than 4? So to achieve the test with pattern, step number 1, inherit with test with parameter. Write whatever you want in the setup and teardown. Write your test underscore p pattern unit test and write the initiate test case and give your inputs. Let's try to run this. And see the output. Hey, it has run 4 times and this is our test patterns. Hi all. After an understanding about the introduction to the Google Test Framework, now we shall try to understand more into the GoogleMocks. So what are these GoogleMocks? When you have a C++ application with you, all that you see is only classes and classes and classes. Some functions must be taking an input of the classes, something must be taking an interface, object, a reference, a pointer. But all of these are all pointing to the classes. So the first question when I ask you to unit test that is, how do I pass a different varieties of such objects to test my function? So Google Test Framework provides you an answer with something called the mocks. What are these mocks? Consider that you want to how do you think the mobile stress testing is done? The stress testing is actually the stress is artificially imparted over the object to test it under the stress. So similar to that, we try to mimic the objects. Artificially we create the objects which look alike the real objects. So more practical into it, you have a C++ class. We try to mimic the class. We try to create a lookalike of that C++ class is called the mock class to test the behavior of the way the other classes interact with it. So that is called the mocks. So going forward, we shall understand more and more about the mocks. We shall understand how to interact with the mocks, how to use the mocks, because this becomes very important when we want to unit test the C++ code. So okay, what is this? Now here I have put in a class diagram. So designed here is about the sample example that I have taken. So this is important for you to understand this, because further in all the samples we shall keep explaining and understanding these again and again. So the sample program that I have taken, the C++ application, is what is it doing is it is trying to scan all the files in the provided input folder and provide you the file statistics as and when required. So this is a very small sample problem I have taken, which I have resolved, and this is a small class diagram for that. So cscan is a small class which is actually inheriting from the scan interface. So scan interface tells the outer world that I have display all files, which can take a directory, and it says I have get file statistics, which can take a path and which can give the file statistics, and it says I can give you back get list output. So this is a scan interface. So what is the C file finder doing? So C file finder is actually a class that utilizes a cscan which is provided to the outer world. So for example, like there is a function called find files in the home drive. So in the home drive, and I provide you the scan object. So it is going to find all the files in the home drive in whatever directory or whatsoever. Similar, we have external drive and file stat. So C file finder is something that is going to use the cscan and do the file statistics for you. Okay, so this is something, a small example. Let's try to understand more about the sample. It's important for us to understand. Okay, and we have something called the find interface. So what is find interface doing here? So the find interface class is trying to provide you the varieties, like it can find the duplicates in the output that you have found. So I provide an input directory, it has 2 duplicate files, say. So if I use the file finder, it tells I can provide you if there is a duplicate. I can tell you if your input has duplicates. So something like this. So for that we have defined a cfind interface, and we have a cfind class for the similar thing. So on the whole, we have now 5 classes. So this is what is the example that we are going to understand further in our project. Okay, so with this understanding, so the question here is now, what is it we are trying to unit test? Say C file finder, I have given you the function. So we are looking at trying to write a unit test for this particular function. if I had to test the find files in the home directory, home drive, then let's understand what is the function doing. It will take 4 paths. It loops into the vector 2 and finds all the files in the input folder. So the scan object that is passed as an input used to call and help in finding the files. So how shall we unit test this? Is a big question. Yes. How is the code flow on the loop on so let's understand the code flow on loop. The scan display function is called. It is possible to test whether it is called. So that is one of, is it possible to test whether the scan is called? Yes, it is possible to test that with respect to the mocks. So basically what we are trying to tell here is, if you have to unit test this function and you have to unit test something that is happening with the scan object, which was your class input, we need a mock class for the scan object. Okay, so now the next question is, how do we write a scan mock classes? So here we come. First, derive the class mock class from the real class. Here our real class is a cscan, so we'll write a mock class for that. Take a virtual function of the real class, count how many parameters it is. Inside each class, write a mock method or the const method, and where the n is the number of parameter arguments. Cut and paste the function name in the first argument to the macro and leave what is left as the second argument. Repeat it until all the virtual functions you want to mock are done. Bit confusing, but we'll see the real example, understand it much better. Scan mock. So as I said you, cscan is the class that we want to mock, but we will take only the interfaces, because only the interfaces can be mocked. I would like to tell you again, only the interfaces can be mocked. No concrete classes can be mocked. So I shall take the scan interface and then I shall mock the scan interface. So this is called a cscan mock, and we had 3 functions there, if you remember. So what we did, it as in the presentation we explained, just for every virtual function write a macro mock method n. N is nothing but the number of parameters. So I write here 1 because my display function display all files was taking a single parameter, that is a string directory. So I make it 1. But similarly, get list wasn't taking any input, so I make it 0. Get file statistics was taking 2 inputs, so I make it 2. So now it's very clear, 3 virtual functions and n is actually the number of parameters, and the name of the function is the first parameter, and the second parameter is just take out the name and just paste it as it is. So this makes your class ready. So you're ready with your mock class now. So what is the next step? Let's go back. Just try to see. Yes, so this was my scan interface, this is my mock class. So we had 1, 2 and 3, and similarly we have 1, 2 and 3 mock methods written here. Yes, once we understand that how to write the mocks, so we should next understand the macro called as the expect call. So what is an expect call? This is a macro that the gmock provides, or the Google test framework provides us to set the expectations on the mock objects. So the first parameter will be a mock object. So what is a mock object? We have created a mock class, and when we created an object of it is called a mock object. So there's a mock object and the method and the matches, and these are the possible ways of testing it. So we will get into this more in depth in the next session, but now we'll try to, since we have now just created a mock object, mock class, we will just try to understand how shall we actually create now expect call out of it. So I have written the sample example for that. Yes, GTest is the function file. Yeah, test mock. Yeah, so what we were kept telling is we want to test find files in home directory, home drive. We wanted to test So we understood, yes, we have to pass an input, but we told that we will pass a mock object and see how the function behaves. So we passed a mock, we created a mock class. Now we create this a mock object. Okay, fine. Now we want a C file finder. Okay, so this is, instead of passing the proper C scan, we are passing the mock object here. Now this is called the expect call. So what is it happening here? So when I call this function, when I invoke this function called the find files in home drive, what happens is the scan mock is passed. So when I pass the scan mock, so this vector is built as it is, and now it will iterate through it, and 4 times I want the display all files to be called. So when I call the display all files on the mock object, so this is a definition of the mock that is getting really called, which is actually a mimic of the real file. So it will really not execute the real production code. Instead it will execute the mock functionality to just tell you that, hey, yes, your find files in home drive is really calling the display files. So what shall we do now next? So now we have come up till writing the unit test for this. So now we set an expectation. We set, when you're calling this function, I expect you to call it 4 times. So expect underscore call a mock object, the function that you wanted to pass, and I say I don't care for the input that is going in, but I say times. I say 4 times it needs to be called. Okay, so let's not confuse you much. So what I'm going to do is I'm going to just comment this and build it. And we shall just see how this one small scan test will work, whether it is calling the whether does it call it 4 times or not. Hey, it passed. See, the test mock is passed. Okay, so it is really calling the 4 times, but I would like to fail this for you and show. See, now I say I don't know, I do not understand, I'm not clearly understanding the functionality. I'll say, hey, I simply expect it to call 8 times. So this is a wrong, so this is not the it's a wrong expectation, so the test should fail now. Hey, it failed. So it is clearly telling expected to be called 8 times, but actually it is called only 4 times and it fails. So this is what is writing of the GoogleMocks is all about. Hi everybody, after understanding how to write the GoogleMocks, now we shall understand much in depth about the GoogleMocks. Here this is explaining you about how to write, how to understand the times in sequence, after, will once, will repeatedly, retires on saturation. These are the in-depth concepts about the GoogleMocks, and we shall see many more examples in this and how to experiment them and write them. Back to our program here. So what I shall do here is we shall write a, now we are trying to understand the normal GMOC. We shall try to understand the times cardinality here now, and we shall try to understand a wildcard. We shall try to understand any type macro. So I know you already know about find files in home directory, how it is written. So the find files in home directory is building a vector of 4 and calling the 4 times the display all functionality. So we expect that the display all functionality is called upon the scan object. So here too, what are we doing here is we shall comment this and we shall write the code. Yeah, so we shall expect simply a scan mock display all function four times. So display all function four times, but what is the input that going in is the first input is this, second, third and fourth. So perfectly speaking, the first input is this, so I should write display all function with this. Please expect a call and scan mock with this input. Similarly, hey, I shall do some copy paste here and say this is the second input and third input and here comes the fourth input. So how is this going to work? This is perfectly four different varieties of the inputs and we are expecting the four expectations. So it is passing, so whatever we have written is correct. So this is one of the ways of expecting the right inputs. So there's another way of writing it. There's a more smarter way of doing this. In case if you are not interested to understand what input is getting passed, I shall say expect and scan mock display all functions and expect four times. And this, what is this? This is called and any type of the value, but the type is string. So this is this is called the matchers. This is comes under the matchers. Times is a cardinality. So any of the type string shall be matched. So all of these are strings, so this should also pass. So I shall build this and explain you. So here we have learned the two things, writing the proper matches. In case you are not aware of the proper match, then you are telling any type of the string and the cardinality too. Okay, so let's move on. Next we will try to understand something about the wildcards. So the matches, any type matcher and the equal, reference, the floating point matches and the string matches. We shall explain you with this and examples. Back over here. Okay, the wildcards. So the wildcard is a simpler thing that is called I can even show you the wildcard here. If I say this, I do not care is called a wildcard. So that's a mistake. Okay. So this is a do not care condition that is called the wildcard entry. So we have tested even the wildcards over here. Okay, so now we shall try to understand just commenting all this so that we are just running one function at a time. Okay, so what are we doing here is I have written a function called find duplicates and set the value. So if I this is a function template, it can take any types. So it finds a duplicate in the input that you have passed, and in the result it will set the duplicates. So as I mentioned here, I'm passing an array, and 6 is latest repeating, so result should have 6. And here result is an array, and latest repeating is A6, so it should have this. So what shall I do here is, I shall simply change this to show you the macro expect underscore equal is working. So this is very simple. Expect underscore equal, or expect that, assert underscore equal, or assert that. So these are some of the smaller things which you can enhance in your macros, which you can enhance in your GMock to understand it better. So here as I said, you expected A0 but A6 is passed, so this is failing. So this is a perfect answer. So if I do this, it passes. So this is one of the examples for expect equal. This is a matcher, and then is the string matcher. You guys have to bear with me for the smaller things. Yeah, string matchers. So what is it that we are doing? Expect that display all files. When I say display all files and get list, the get list will give me the list of the strings. So I'm trying to expect that the first parameter is having this. So this is a substring, a regular expression to be passed. As substring takes a regular expression, you can go into the GoogleMock and read all this. Contains, downloads, and string is not equal to. So these things are passed. So this is simpler. The next is the class templates with string. Okay, there's one smaller thing that we need to understand when we are trying to use a class template in the GoogleMocks. When we are using the class template, we need to append underscore t to our mock functions to understand it better. So here I have written a class template as a sample. So what is the class template doing here? It's a find mock which can take, it is taking two types, and it's a find mock which is taking two types, and it has a function called find duplicates. The find duplicates take two types, and it will the vector is an input and the result is the resultant of whichever is duplicate. So I have just emphasized or extended this example so that it can take any varieties of the inputs and experiment that. So when I write a mock for this, the only thing to remember here is underscore t. Whenever you're writing a mock for the templates, you have to have the underscore t, otherwise it should fail. So I say the find duplicates function is having an underscore t. So to experiment the same, to explain you the same, I have written here the two unit test cases. One is the templates with string, which is taking a string find mock, and I'm calling the expectation on find duplicates, and I templates with int. I create a mock object with int and find duplicates. So this should work. So I should build this. The only point to remember in the templates is to use the macro underscore t. So this is working fine. So I think we shall move on. Next are the actions. We shall do a bit of reading and come back. Actions. What are the actions? Actions specify what a mock function should do when invoked. So some of the types of the actions are written reference. So you're actually asking the mock function to return a reference of what you are forcing it to be written. You're returning a pointer, it's well explanatory, and you're trying to save an argument. You're forcefully saving the argument a mock function has to your local variable. Save an argument pointing reference to. And there are some more actions that is called invoke, where your mock function can invoke a static or the global function or a functor with the parameters that the mock function has. and there's something called with arguments. So you can pass the 0th or the 1, 2 or whatever the arguments of the mock function to the function of your choice, and do all. You can specify the action, the number of, not just one action, but 1 to n actions to be performed on the mock functionality. So we shall see all the examples working now practically. So here we have the set save argument. So before we start working on this, as per the guidelines, we first have to understand the production code and then come and write a test unit test case. So the function under test here is find file statistics, which is written in the C file finder class. So if I go here, what is this file statistics doing? The file statistics here is, we have a scan reference which is actually passed when you create a C file finder object. So I ask the scan reference to give me the list. So whatever the list is passed, for some reason there is a string added to it, and then we ask again the scan reference to give me the file statistics, and I save the file statistics to my local variable, and very simply we are trying to find out the file size here. If it is less than 0, I say an error, or else success is written back. Okay, so if I start unit testing this, what is the points of interest to me? If you see, this function is a bit tricky. The point number 1 to consider here is the sample vector is actually hidden and it is not exposed as an input to here, and the sample output is also hidden, the file stat, and it is not exposed here nor here, only you have the output here. So the points of interest here is, how do I actually take control over these parameters which are getting to the scan get file statistics of the scan reference. Okay, so let me not confuse you much more. Let's get into the writing the unit test for the find file stat. If I go here, okay, find file stat, let me not do this first. We are trying to explain you here the save argument action. Save argument is nothing but I'm trying to save an argument of the mock function into my local variable. So I shall not do it. I shall write a small normal unit test. I shall write a normal expect call without any action. So what am I expecting here it to be done is, it should, if I see here, its defaulted value is 0, I should get an error in the stat, and file size is 0 has been expected over here. So let's see what is happening. So here what we are trying to do here is, we are trying to save the argument to our local variable and see if it works. Okay, so it says the expected is 0, but the size was this. So in case I save the argument and see the value, I should be getting rid of this thing. So what actually happened here? So when I didn't save the test, I have here file size is actually the file size has been declared here as this, and I'm trying to save the argument pointer here to the one argument, and so what happens is the file stat is overridden to value 0 because the 0 is defaulted here. So I get this gets overridden with 0. So we are trying to experiment, or we are trying to tell that the save argument pointy is working. Okay, hope you're all understanding. So the next interesting point or the action here is set argument pointing. Save argument is you are trying to save it to your local variable. Set is we are trying to force our input to the mock function. So this becomes more interesting. So what we are trying to do here is we have a file stat which is having the file size of something, and we are trying to force into it. So what should happen is the defaulted value of 0, which was giving an error in stats, should get erased and it should return you success in stat. So I shall comment this code. So this should pass because we have passed this. So what shall I do here is I will first, as usual, I'll make it a normal mock function and tell you this fails because we are not trying to save anything. We have just return a mock function. We are not having any control over the input variables. So in case I do this, yes, the expected is success, but which was equal to error. So sorry, expected was success, but the real result was error stat. So in case I try to override this value and save my function, so there will be a change in the result now. So here we are trying to understand the set argument pointy, where we forcefully wrote the test data argument into the function. Okay, so we are understanding quite a lot of actions. The next action out of our interest is invoke. So when you call a mock function, invoke shall add an action over the mock function to call the function that is being passed as the input to it. So what are we doing here? We'll once invoke function to be called with the parameters of the mock function. So what are the parameters of the mock function? Get file statistics shall take a vector and a file stat. So I have also written a function to be called a vector and a file stat, and I have just, what I have tried to do here is change the file path and override the value of the file size, just to make sure that we are trying to change the values that the mock function is really having. So how is the useful of this invoke the invoke action is, whenever you want to have a control over your unit test and add some extra functionality to it with the inputs that you are passed or the outputs, that is parameters of the mock function, the invoke is very helpful to you. So here again, to repeat, action invoke, function to be called. This function will be called with the parameters that are passed here. So I have completely overridden this value, so the file size to be 10. So the only way to understand is the error in the file stat. So we shall see what will happen here. Expected declaration 145. There is a problem. Okay. I think it's because of this. So we have overwritten the value to be 100. So 100 is a success in the stat because we have got some. So it is being passed. So now this is to show you that really the function is called and we have overwritten the input values of the. It's a pointer and we have overwritten the pointer values, and hence there is a change in the way the mock functions are called. There's a change in the way the mock functions are behaving. So this we are done with the invoke. The next action that is of our interest is test is do all. As I mentioned to you, the do all shall do all the actions that is specified within its where is specified as the input to it. Here I am trying to set argument pointer of the parameter 1 to test data. I am trying to save the arguments 0th argument to argument 0. So how shall we experiment this is the test data, the argument 0. I am trying to see what is in the argument 0 and we shall see the result because test data is overwritten with the value of 110. So we shall see that all of these actions are executed one after the other. The only point we have already seen how the set argument pointer works, save argument works. So now do all will just make sure that each one of them is done all together. Yes, it's working. Okay, I would like to explain will once also here. So what is the will once doing? It is telling the mock functionality the expectation call that you have to expect the get file statistics just once. It's basically the cardinality number of times, it's just one. So will once will do that. So I explained you one more concept. Now we shall move on. The next interest is with argument. We have understood the action invoke. Invoke shall call the function with the arguments of the mock functionality. Here we shall give one other predefined information telling only with the argument 0. So only with the vector argument we shall call function with arguments, or we shall invoke a function with just the 0th parameter. So what are we doing here is we are just appending something over here. So we should be seeing this working. This is just to explain you how the invoke function with only the parameters that you need would be passed. That is with the with argument macro. Hope I'm not very fast. Yes, so we are able to test this too. So we are done with our actions all. Now we shall move on to nice, strict and the naggy mocks. What is a nice, strict or the naggy mock? If the mock method has no expect call, but it is called, the GoogleMock will print the warning as uninteresting call. So to suppress all the uninteresting calls, we use the nice mocks. So nice mocks are not actually strict, or strict are not nice. So there is something like, in case if you have forgotten any of the expect calls, the GoogleMock will start complaining to you. So we shall understand this better with an examples only. The nice mock. Hey, look at this, what I did. Find duplicates example. I do not have any expect calls. But will this work? Yes, it works, because we did one small change here. Every time we just called a find mock, but this time we made it nice also. So we just called nice mock. What shall I do here is, first, in fact, before explaining you all this, I will keep it simple. Yes, this is a small thing. What shall happen? The point of interest here is, we have created the mocks. So I'm calling a find duplicate example, and we already know we need an expect call, but I comment over here and I have created the rest of the things. So what will the GoogleMocks say? Hey, GoogleMocks is complaining. It says uninteresting mock call, because default it expects you to call almost all the mocks. So the only way to avoid this, say in case you don't know what mocks to call, the only way to avoid it is mock provides you something called the nice mocks. So the moment you put a nice mock around your normal mocks, it shall not complain about any of the expect calls that you have forgotten. Now you can see this will pass. Yes, it did. So as I told you, the default will be a strict mock, and the nice mock you explicitly provide. The strict mock, when you say a strict mock, the gmock will not let you forget any of the expectations, and you have to specify all the expectations for it to pass. So here I have written something called a strict mock for the things, and it shall work as expected. This we have already seen. I write an expect call, scan mock get list, and will once return a reference of the argument 0. So this shall pass because we have taken care of all the disciplines. It does not match with the get list. Okay, find duplicates example, find duplicates example, find duplicates example, find duplicates. Oh god, I've done something here. This should be fine. I have written a wrong expectation call, so it was complaining wrong. So back to our strict mocks. So the strict mock passes provided you give all the expectations. Say in case I forget to give this expectation and build it, the mock should complaining telling about the uninteresting mock call. Yes, it does. So this is a small experiment for you to explain like how important is the strict mock. Okay, back to the presentation here. At last we have something called the GTest flags. There are some flags that you can use for the more better informations. The gmock catch leaked mocks. Do not repeat the leaked mock objects as the values. So default gmock takes care that any of the memory leaks are reported to the user, but if you want to suppress that, you can use gmock catch leaked mocks. And then do not then we have the verbose level of then we have the levels of information that could be passed. If you use the flag gmock_verbose, the level whatever you need to see, so info, warning, and the error are the different info levels available, so you can have the more in-depth information. And the GTest stack trace depth is equal to 10. So this will give you more information about the stack trace on any of the failures. So this was a small presentation about how to use the GMocks. Hopefully I have provided you enough information to work with the GMocks. Thank you.